Now I know you want to hear about wires. So we're going to do some wires. You guys remember your RJ45 connector we made, right? When we made our connector, we had RJ45 wiring. Okay, what were we doing? B? 468B was our scheme. So if I have pin 1, I'll just write them 2, 3, 4, 5, 6, 7, 8. All right, you guys remember pin 1 in our scheme was white and orange, and then we had an orange wire here. Good. No, they both ends need to be the same as the key. White, orange, orange, white, green, blue, white, blue, green, white, brown, and brown. All right? And how did we wire? This is what it was on the test, right? So this is a PC. If I'm going to connect to a switch, what does the other end need to look like? That was the cable you actually made. So pin 1 on the switch. I'm going to connect my PC to my switch. I need that white-orange wire to go over to pin 1. All right? This orange wire goes to pin 2. So that means over here it's white-orange again. You guys see that? It's the same wire. The orange wire goes over here, and we just make the connector that way. So I'm going to have the white-green wire. I'm going to stop drawing them. Well, actually, I just need these 4. All right? And what's going to happen is on my switch, I will transmit. So when the switch is going to send a signal, it uses 3 and 6 to make its circuit. So you guys see that? The green wire and the white-green wire. Why is that important in terms of crosstalk? Y'all remember that? The green and the white-green wire, they are twisted together inside. You wire them kind of funny, isn't that weird? These blue wires are for your phone. If you,
I might have wired that thing initially wrong
then you might have.
Yeah.
So the switch transmits on 3 and 6, and it's important that we use the white, green, and the green, because inside the cable, those are twisted together. All right? And we want to diminish the crosstalk. All right? And if we're transmitting on 3 and 6, guess what we're receiving on? One and 2. Okay? So here is, for the switch, it's transmit, and over here, it doesn't look like a T. And here is receive. Okay? What do you think it is on a PC? If the switch is receiving on 1 and 2, what's the PC doing on 1 and 2? Transmit. So it transmits on 1 and 2, and it's going to receive on 3 and 6. Groovy times? Now this is how it works here to get it. It's how it worked up here too, but it's how it works down here, that I can send from a PC and have it come out here still, you know, and this is where they're sending, and then I can receive on I'm receiving on a different cable, and so I got 2 different signals going on. That's how I can get full duplex. Up here, I can transmit, but notice I still have to receive the collision detection stuff. So I don't get to use the whole thing of both cables. We're all over that, right? All right, so there's receive and transmit. Now, you guys remember our core switch? What if I want to connect my switch to another switch? All right? So already we said this switch is going to receive on 1 and 2. This one transmits on 3 and 6. What is this switch going to do? What's it going to do on pins 1 and 2? You know that's a trick question. It's going to receive, because that's what switches do on pins 1 and 2. Are we good here? When you buy the switch, it just does what it does. It's a switch, okay? So we still receive here. All right? Now, I say that with sort of a cautionary note. Your PC now, they have fancy PC network interface cards that will detect if you're connected, say, to another PC, and they will actually sort of swap where they receive and transmit from. If you buy a switch at Best Buy that's designed for consumers that don't know what they're doing, they will also do it, okay? So the switches I brought to class, the black ones, and we were plugging them together. Oh, we didn't plug them together, did we? When we plugged them together, those ports will auto do that too. But a good,
So we don't know what we're doing.
well, a proper switch receives on 1 and 2 and sends on 3 and 6. Okay? If you buy, a Cisco switch and you need to link 2 switches together, this is what it's going to do. And so what we need to do here is I need to connect my receiving pin to my transmitting pin. So over here I'm going to have white-orange is going to be on pin 1, and then over here white-orange is now on pin 3. So one end of the wire it's 1, the other end it's on 3. So I'm wiring the 2 connectors differently. You guys can see that? So 2 goes to 6. You see that? Now it's orange, and it's still orange over here. So one end starts with white, orange, and then orange. The other end starts with, and I'll just draw this in, this one starts with white, green. Oops, that's not the right one, sorry. And then green. See that? White, green. So one end of this connector starts with white, orange. The other connector starts with white, green. This is awesome. Okay? So, PC to a switch, nice, simple, both ends exactly the same. That was the question on your exam, on this exam. Guess what the question on the next exam is? This is called a crossover cable. That's one word, sorry. It's a crossover, but they could just call it a crossover cable. Right? So you can see how they cross over. And those of you that have followed along in the book when you were doing your RJ45 connectors, you'll notice that this scheme over here was B, and this scheme over here is A. And so wiring one end of a wire, one scheme, other end of the wire, the other scheme, that gives you a crossover cable. This is fun stuff, huh? All right, one other thing to note. I've been talking about, so I want to connect a switch to another switch, right? So out of this switch I might have all my workstations. And this, remember, is my core where I put my servers in, and I connect my other switches to it. So here's my other workgroup switch with lots of stuff coming out. Oops, that's not a switch, that's a workstation. Okay. So I got lots of PCs out here, and I've got important stuff in here. Remember, this is my trunk line, carrying lots of stuff. So the cable that connects a switch to a switch is a trunk line. Follow me here? So this cable now, this crossover cable, if I'm using copper, is going to be the thing that carries all of those conversations. If you're actually using an unshielded twisted pair crossover cable, most people use fiber here, but that's okay. If you're going to actually use an unshielded twisted pair crossover cable, this ends up being a really important cable, okay? This cable that we made a crossover cable. And this is the kind of thing that if you're looking, for example, if you're standing in front of this switch and there's all these ports, and I told you about having live and not live things, there's times when, as a network administrator, you approach one of these things. I'll make the hand if I'm pulling out a plug. So I got something plugged in here, and I want to pull it out because I don't want to use, I want to use that port for something else. Guess which plug I do not want to pull out? That's the one this is plugged into, right? Because if I unplug this one, this whole switch is now off the network. Are we good here? Normally, a crossover cable is red. Sometimes they are orange, okay? I'm telling you that now because don't ever make a normal patch cable red or orange. If you want a pretty one, you can use blue or yellow or green. If the dull people use a gray one. But a red one or an orange one means this is a crossover cable. And like I said, the cool kids use a crossover cable. You know, a Cisco switch, Brocade switch, HP ProCurve. These are all going to have where they don't auto-negotiate because they want you to put in the red switch because you're supposed to know what you're doing, right?